Hello people, I'm Torakis, security engineer at Skroutz. In this presentation we're going to talk about provisioning a SIEM with code and about the whole thing with the infrastructure as code trend and the workflows it suggests sometimes to the security teams. Basically, to introduce the concept of SIEM is the thing that might inform us if we're getting hacked and consists of four basic components. First of all, the search engine that stores and searches the logs and generally does the heavy lifting. The various data shippers and the other collectors that deliver the logs to the system. An engine that does log correlations depending on specific rules, exceptions. And finally, a system that alerts us on successful correlations in various ways, like emails or Slack or whatever. At Skroutz, we use Elastic SIEM with Kibana, Elastic agents, and that kind of stuff. Our data sources vary from AWS to OpenLDAP, so it contains all kinds of things. Finally, we use a very small project, Praeco, which has alerts and command triggering. So here we deploy a SIEM completely from scratch, but in Kubernetes. At Skroutz, we use Kubernetes with a pretty standard open source setup, like Nginx set manager, with Let's Encrypt certificates, external DNS, generally that kind of stuff. Generally, we use heavily tested stuff that work well, both on-premise and on cloud. So, to deploy the SIEM, we use an open source project called Blue Baron, created a while ago by a colleague and me. The repository consists of Terraform modules and examples that deploy Elasticsearch, Kibana, and the rest using Helm. The project is inspired from Red Baron, another Terraform repo for offensive cloud infrastructure, such as C2 systems, redirectors, payload servers, and such. And it works on all kinds of Kubernetes clusters, like from Minikube to cloud managed services, anything goes. This is how the empty bed where everything will get deployed looks like. And this is how the complete picture looks like and the deployed services that get there. So all these services get a TLS-enabled endpoint for us to reach and consume. And also their interconnections between them are all TLS-enabled. Finally, this way we end up with a default SIEM deployment that has alerting, command triggering, dashboards, and exotic log collection. So now George will explain to you how to configure the Elastic Stack as code.
Hi, this is George. I'm a security engineer at Skroutz, and we're going to talk about configuring the Elastic Stack as code. Logs. Logs are important. They are generated by services and applications. These logs provide information for what is happening right now, and this kind of information needs to be transformed to provide a value to us or an administrator. Bits and fluentd, data shippers and data collectors are used to gather and push these logs. These sets of data are sent to Elastic indices or indexes. An index has a structure predefined by an index template, and the incoming data are enforced to match the structure. The incoming data might need some transformations, and this is achieved by ingest pipelines in steps using processors. A processor might be a simple addition of a field, or a deletion, or a modification, or a calculation. Our indexes can include data retention policies in defined phases. The phases are hot, warm, cold, and then deletion. Finally, snapshots are taken regularly as daily backups, and all of these components, of course, can be configured from Kibana, but it has to be done every time a new setup is deployed. So, we create a structured, portable, and auditable way to maintain these configurations as code and do it only once. Alright, the same applies for users, roles, and privileges, for the cluster and Kibana dashboards. Roles have specific and can have multiple privileges. A user might also hold multiple rows to perform each action. Everything can be configured, of course, by clicking and dragging and dropping and huffing from Kibana, but if you do it as code, you do it only once, and you have the ability to maintain it, to review it, and to monitor any change. The Elastic Stack has multiple moving parts, and its deployment includes organization specifics. So you have to set up something according to each organization's needs. These questions might look familiar to you. Tracking, rolling back changes, retaining, backing up logs, managing users, adding, removing, whatever. Clicking around Kibana can be from tedious to impossible. So we try to solve all of them with the as code approach. Now for a real example. This is an actual module created to define a composable index template, or a legacy one. You can set up its type, name and policy, the alias, the intervals and the shards and patterns shown on Kibana dashboards, even the pipeline and the mappings of special fields, such as an IP address. Some fields, such as the final pipeline and the static template mappings, are of course optional. This way you can configure and create a new template only as code. Down below you can find an open source Terraform provider for these configurations from Phil Baker, and we created modules based on this provider. The Snapshot module. The Snapshot module defines the cron format schedule, the snapshot name, where to store the backup, and the indices that need to be backed up. The Index Lifecycle Management module defines, or ILM, defines the phases, the hot, warm, cold, and deletion, alongside the max size and the days passed for each phase. That means if we reach a threshold of gigabytes or a date, we can move on to the next phase. The ILM module might need to wait for a snapshot. Pipeline. The pipeline module specifies some basic fields such as name and description. The type is a custom field because our module can accept a JSON structure or an inline penless script as a processor. Some new lines and double slashes need escaping to work their magic with both processors, and it's not the most beautiful thing, I know, but at the moment it does the job and it does it pretty well. Finally, the actual processor. This is the heart of the pipeline. This processor uses both a JSON and a penless script in two separate files for cleaner code and better reviews probably. We could just output a whole script in one line, but this is more readable. This processor, for example, includes a grok pattern that maps opened up log fields to ECS, and a penless script that adds and calculates a new field if the event was captured in company's off hours. So, with this script, you can catch actors if they work at midnight. Thank you. Now is Kiki.
Hello, I'm Kiki, and I work as a security engineer at Skroutz. And in this part, I'm going to explain to you how we manage to keep Elastic SIEM rules, exceptions, and lists as code. Let me give you an example to explain how exactly they work. Let's say that we want to create a rule to catch any DNS that is not to Cloudflare. And the exception container contains two items, so as not to trigger the rule only when a Chromecast device is going to Google DNS, and also when the traffic is coming from guest Wi-Fi network. The IPs of Chromecast devices are badged as values in the list item. Structure of Elastic rules is as defined by official repo of Elastic detection rules. Rules are expressed as TOML files, describing the rule, giving some necessary properties such as the name of the rule, a time range from when to search indices, for example, file read and packet read, and the type of the rule that can be either a query, a threshold rule, or an EQL rule. Here, a very interesting thing is the reference of exception containers. Keep in mind that in this way we cannot create exceptions or lists with this syntax. So, the way to overcome this is by creating exceptions as defined by Elastic Exception API, which can be expressed as YAML files. The YAML file contains the part of the exception container in which simply we describe the items, where every entry does have a log field and a value or a list to get checked against. Finishing the as code part, the lists don't innovate, they are defined by Elastic Exception API and expressed as YAML files, likewise the exceptions. The structure of a list consists of list containers and items. A list container describes the list items actually, and the list items include the values of the container. That is the IPs of the Chromecast devices in the example above. Good to mention that the interconnection between the item container and lists happen through directory structures. As anyone could imagine, maintaining such a complex structure for each SIEM rule is not a piece of cake. That's why infrastructure is one way. So every SIEM rule is implemented by a Terraform provider, abstracted by a repository template that manages the YAML and TOML files of rules, exceptions, and items. Hence, the only thing you have to do is to write your own TOML file and YAML file. All this code is open source, managed with GitHub workflows for automatic Terraform plan and apply, integrating with the official Elastic Detection Rules repository. Git is of course our best friend to review change management. This way, no one is able to make a change on the repository without being firstly reviewed by the teammates. Thank you very much. Feel free to ask any questions.